Alibaba Group has released Ovis 2.5. So this is a visual reasoning model. What is special about this is that it integrates a native resolution VIT transformer which processes images at their original variable resolutions, thereby preserves both fine details and global layout for visually dense content such as charts and diagrams. There is also an optional thinking mode enabling users to trade latency for higher accuracy on complex inputs. So this is a visual reasoning model, and this has Apache 2.0 license. This is a model with 9 billion parameters, so it will require 18 GB of GPU VRAM to run it. So let's look into some use cases where I tried this model on their official space over here, and then let's come back to a little bit about the architecture of this model. What they are claiming is that this is a very good model for chart and document OCR. It has deep reasoning capability. It has native resolution perception, broad task coverage, right? So it demonstrates leading performance on image reasoning, video understanding, and grounding benchmarks. So here they've compared it with, say, GLM 4.1B, 9 billion parameter model, GPT-4o. They've compared it with Quen 2.5VL, 7 billion parameter model. So among this 9 billion, 7 billion, 8 billion parameter space models, this model seems to be performing really well on various multimodal reasoning tasks. So first, let's look at an example which I tried over here in this demo. So I uploaded this image of an Indian dish. This is actually neer dosai. This is not appam, but no, the model says this is appam, which is fine. Okay, both are made of rice. So I said, given this image, can you estimate the number of calories? So I put max tokens for thinking, max tokens, thinking budget is full over here. And it estimated this dish to be appam, quite close with curry as an accompaniment. And then it says 3 medium-sized appams. Each appam weighs around something. It does this calculation over here, and then it says that okay, fine. So probably it is 75 kilocalories. Then for curry, it says this looks like sambar, but this is actually chutney. Okay, not sambar. Maybe that's fine. So it's kind of mistaken this over here, and then it gives some estimate. Okay. Overall, it is around 200 to 250 kilo. Fine. Could be sambar. This could be right. So I gave another thing over here. I gave this video. This is from the continuous continuous thought machines. This video talks about a single neuron. Okay, and I asked this particular model to explain this video. It's actually done a very good explanation of how a neural network or attention-based model processes sequential time series signals. So it talks about starting with a minimal data point. It talks about introducing the synapse model, which is what is explained in this particular video. And then it talks about this particular synapse model over here. It gives a very good explanation of this particular video. Okay, so it's given the shaded green waveform, purple waveform, raw versus filtered inputs. The purple is for the synchronization, like synchronization of signals. Then this attention synchronization it explains over here, right? It's given a very good explanation of this particular video. So I liked how it has explained this, given this video explanation. Okay, so this was another one of my favorite tasks where I gave a Delhi metro map. This is complex. Only I've seen bigger models like Gemini 2.5 Pro work on this use case where I give a Delhi metro map and I ask for a navigation from a station on the green line to a navigation on the station on the violet line, right? Tikrikallan to Old Faridabad. It kind of misses out on this. I've seen all smaller models kind of perform poorly on this particular tasks. So they have many other examples over here which you can try out, right? Over here in their official space. This is another task which I gave up, which I gave to just look at what is the OCR performance. So I gave this image as input, and then I asked like, what is the cost of 2 jamuns and a plate of halwa, right? So it is actually 2 jamun is 48.50 into 2, which is 97, plus a plate of halwa is 64.75. Okay, so price of 1 jamun, it says correctly as 48.50. Over here, OCR goes for a toss and it says 61.25. It's actually 64.75. I can read where the model is kind of made a mistake in the OCR. But the calculation is correct over here. So price of 2 jamuns is 97, which is correct, the first part. Because this is 64.75, which is read as 61.25, there is a slight error in the calculation over here. Okay. But it does a decent OCR over here. It's kind of made a mistake over here with respect to 64.75. It says 61.2. So this was another image which I tested it on. So this is a nice model for visual reasoning, okay, which also has a thinking mode. So you can also specify a thinking budget as well over here, right? And they claim that this model has very good state-of-art chart and document OCR performance. It could do multiple things like image reasoning, video understanding. Okay, so how does this model look like? So you have multimodal input. You have a text tokenizer and a text embedding, right? You have a native resolution vision image transformer, which converts this original images or multimodal input, could be video or images, in their original resolution. And then you get visual tokens, which are then converted into embeddings. And it makes use of a Qwen3 LLM decoder, taking both this textual embedding and visual embedding as input interleaved. That is what it looks like this. And then it generates the Qwen3 LLM decoder generates the text output. Okay, so that is the architecture over here. And what they are saying over here is that they have used chain of thought training for post training for improving this model for reasoning process, right? But they have also incorporated reflective reasoning, including self-checking and revision. So that is what they are saying, which has improved the performance over here. Okay. You can also go and try out this particular model on a local instance. It will take close to 17 GB of VRAM. They've given the code over here on how you can try it out. They also have a GitHub page where you have, the Gradio demo as well. So you code for the Gradio demo as well. So you can also check it out. You can do a local installation and check this particular model. It's interesting that now we have a lot of choices for visual reasoning models. With every now and then you have an open source model coming up with better performance than the previous models. Okay. So they have their benchmarks and other things over here on various various benchmarks. They have done the comparison over here with Gemini 2.5 Pro as well, and models in the similar space, similar parameter space. Okay. So this is a very good model, I would say. So you can go and check out this particular model on your visual reasoning tasks. So this is a short video on Ovis2.5-9 billion parameters visual reasoning models from Alibaba. I'll be putting all the relevant links in the description of the video. Do check it out. See you in another video.